Hi everyone, welcome to machine learning, and today we want to dive deep into logistic regression, one of the most fundamental machine learning models, and it is mainly used for binary classification. So today we are going to use breast cancer dataset, and we are going to use tumor features to identify malignant tumors, and also malignant tumors which are cancerous, and also to identify benign tumors which are non-cancerous. So we are going to load the dataset. There are two ways of loading the dataset. You can go to File and Open File, and you look for the dataset where your dataset is. So today I'm going to use the load function the other way, and I'm going to say breast cancer data dot RDA. So that's my dataset, and it is in the description. You can download it. The next thing is just to view the dataset to see more about that data, which is BC data. So where I got this BC data is the data that is in this file, breast cancer data RDA file is the one that holds this dataset, which is BC data. So you can view it. So you can just have an understanding of what's happening. We have mean radius, mean texture, mean parameter, area, and smoothness. And then the diagnosis is our response variable, and all these are our explanatory variables. So the next thing is maybe to look at the structure of BC data, right? So we can see that all these are numeric numbers, and we have an integer for diagnosis. However, we want our diagnosis to be sort of a factor with two levels, because it is going to have either 0 or 1. We can confirm that by saying levels, then as factor. If we convert this to a factor, then BC data, then we call our diagnosis, right? So we want to see how many levels we have. So we have two levels, which is 0 and 1. So that once we have these few levels, it means you can safely convert it to be a categorical variable, because it has two levels, which is reasonable. Then the next thing is just to do your analysis, just to visualize your data set, do some density plot to see skewness within your dataset. So the first thing I'll do is I'll look at the mean radius. But before I do that, I want to convert the response variable diagnosis to be a factor. So I'm going to create a new dataset, which is plot data. This is a new dataset I'm creating, and I'm just taking everything that is in the BC data, then I'll make my changes in the plot data. So now I'm going to do this. I'm going to add a new diagnosis. I'm going to add it into the plot data, and I want it to be as factor BC, then data. So what happened? Oh, okay. I want this one, the diagnosis. Yeah. So right, so the next thing is just to confirm now the structure of my plot data. Right, so you can now see diagnosis is now a factor with two levels, which is perfect. That's what we wanted. Then the next thing is now let's do some plots. So we are going to use ggplot. It's great for visualization. ggplot2, that's the library. And the next thing is to create a g1, that's our first plot, and it is going to be ggplot function, and we specify the data, which is plot data. Then then we are going to specify the x-axis, which is we are going to start with the mean radius, right? And the next thing we are going to fill, we want to see different radius for either a 1 diagnosis or a 0 diagnosis. So we're going to use fill diagnosis so that we can compare. Then the next thing is geom density. We want to do a density plot, and the density alpha, that's the transparency, is equal to 0.5. So it depends with the one that you want. And the next thing is to work with the theme. So I'm going to say theme set, and within theme set I'm going to say theme pw. Then I'm going to look at the font size, which is base size, which is 22. That's the one that we want to work with. So that is the font size. Then the next thing is now removing the border. So element, it's going to be panel dot background. Let me start removing the background. Element blank, it means I don't want it. Then panel, I want to remove the border. Element blank, then I want to remove the grids now. Panel dot measure, element blank. I also want to remove the minor grid. Panel dot grid, element blank. Right, so I've done this. I'm going to also work on my labs, which is my labels. I want X to be mean, because we are dealing with mean radius. And title should be malignant. Those are the cancerous versus benign, that means non-cancerous. Then I want to fill, my fill should be, this is the diagnosis. Then after that I'm going to add the scale fill. I want to change the colors. Scale dot fill, scale fill, manual. Right, so on this one I'm going to say, what does 1 mean? So since I have 2 levels, I have 1, and 1 means malignant, which is cancerous, so I want it to be red. And the 0 means benign, which is non-cancerous. I want it to be blue. Right, I think that's it. Then I also want to work on my labels. What does 1 mean, and what does 0 mean? So I'm going to say 1 means malignant, and 0 means benign. Non-cancerous. Right, I think that's it. Then let's see how this plot will look like. Right, so it clearly gives 2 distribution, one for malignant and the other for benign. And you can see that the radius for benign is quite small than the malignant. Okay, which is fine. Then we can also do that for all other variables. So let's see, for the next variable, I'm just copying this code. So our next variable was mean texture. Right, I'm just going to change here. Right, this is going to be 2. Right, then the other one is mean. The other one was mean smooth. You can see that here we can say names, because we want to do it for all plot data. You can see we had mean radius, mean texture. So the other one is mean parameter. Okay, perimeter, mean perimeter, then perimeter, then this should be 3. Then we can do it for the remaining ones. This is now 4. This is 4. The other one is mean smoothness. Make sure you write the spelling as it is here, but here you can write any kind of spelling or different caps, the capital letters or not, but here it should be the same as what's in your data set, right? Then the other one is now texture, perimeter, area. We are left with area. That's the last one. All right, let's see. Right, so yeah, these are our plots. So if we are to run everything, we see different plots. Right, so this is the first plot. This is for radius, and this is for mini texture. You can see that benign is bigger than the malignant, and yeah, so just get to know more about your data set. Mean area, and the malignant is bigger, right? So yeah, that's pretty much of it. So the next thing is it's hard for us to compare these plots by opening one and seeing different. It gives us an opinion, but we can just have all of them on one place. So to do that, we can create another plot using boxplot. But however, we can't use our data set as it is now to make it a boxplot. It's going to be difficult, but we can actually transform our data set so that it will be ready for a boxplot. So what we are going to do is we are going to use a library called Reshape to change the shape of our data set, and we'll use a function called melt. So I'm going to say melt data. This is another variable, and this is just going to be melt. That's the function that converts the structure of a data set. Specify the data set. It's going to be plot data, and you specify the ID variable. We are going to use diagnosis, and the rest will be converted. Right, so just for you to see how it converts the structure, I can just say view. Right, so you can see now we have 3 columns, the one with variable, diagnosis, and value. Right, so with this you can easily create a box plot. But however, we want also to change something. We want to change the labels here. We don't want our variable naming to have this kind of structure. We can change it. So to do that, we want to create a new variable, which we are going to say data. The new variable is going to be called var2. This is optional. If you want to work with those column names, it's still fine, but we can create a new one, and we replicate the name radius, so that we want the radius variable to have this name called radius, not radius mean. We want it to have a better name. Then we want to replicate it how many times, and row the size of our data set, which is data. Right, so what happens is now you can see we have radius throughout. So we have replaced, we just created a new variable with this name. Then the next thing we are going to do is to now replace the radius with the actual name for each variable. So I'm going to say mdata, and then mdata, then I say var2, right, in var2. So this is my variable. In var2, I want wherever there is when the variable mdet, then variable, when my variable is equal to let's say texture, right? So I want it to be named texture. Oh, so actually my variable will be mean, then colon mean, then texture. So I want it to be texture, right? So that means I'm replacing my variable where it was written var2, where it was written radius, and where the variable is mean texture, it should be texture. So that's fine. Then I'm going to do that the same for the other variables. So I'm saying var2, in my var2, replace radius with this name mean. So this is going to be mean smoothness. I'm just calling my variables in my dataset, and I want to replace it with smoothness. So where there was smoothness is now smoothness in var2. Then the next thing is area. Then area. The next thing is should be perimeter, mean perimeter. Right. So after doing this, we can now check our data set. And remember, for radius, for mean radius, I'm not doing anything because already there is radius in our new data set mdata. There are certain rows which are called radius, so I'll just leave them. I'm just going to replace each time when the variable is mean smooth with smoothness, it's mean texture with texture, and as follows. So let's just view this data set and see. Right, so you can see where there's mean area, we have area. Where there's mean texture, we have texture. So that is fine. Then the next thing now to do is to create the box plot. So I'm just going to say I think it's G7. I'm going to say ggplot. That's my function. And the data now is mdet. Then AES. It's going to be my y is going to be the value. My x should be the diagnosis. Then my fill, I want to have two plots for every variable, and I want them to be different by diagnosis, right? Then I'm now going to create my box plot, and I'm going to say alpha is going to be 0.5. Then the next thing is the facet rep, because I want facet rep now works in creating different plots on a single sheet. So I want the different plots to be on the var2, which contains different variables, and I want also the scale. That means they should not be on the same scale, so I want it to be free. It should not be fixed. Then the next thing is to deal with my theme. I'm just doing the same thing. Theme set, then theme pw, then page size 22. Then the next thing should be theme. What I want my theme to be, I don't want the background. I don't want the border. I don't want the grid lines. I don't want also the minor grid lines. Then I think that's all. Then I can also put the labs. That's the labels. X should be the diagnosis. Then title should be malignant versus benign. Then field should be diagnosis, right? Then after that, I'm going to work on my scale manual, scale, then fill, right? I want my values to be equal to, specify that one should be red. So I'm just doing the same thing as I've done before. For density plots, should be blue. And I want the labels. One should be equal to malignant. 0 should be equal to benign. Right. And we can see the plots now. Right. So because of the sizes, it's not coming out very nice because of the sizes. Let me give it time. Oh yeah, so here it is now. You can now see we have different values for malignant and benign. So you can see for area we have less malignant, and the same for perimeter and radius. Yeah, so it's a way of visualizing more about your variables, which is okay. So the next thing now is to do logistic regression. I think in our next video we are going now to apply logistic regression to see how these variables impact the diagnosis, right? So the first thing was for us to do visualization, to just familiarize ourselves with the data set, right? So thank you so much for watching. See you in the next video.